everyone, my name is David. Uh, if anyone doesn't know, I'm the author of the Sharpify um, family of packages, and today we'll take a look at some demo of Sharpify.CommandLineInterface, which is essentially a command line interface framework for creating such tools. Uh, it isn't tied to system.console, and it can be embedded in pretty much anything as long as it receives the input, which it can in a form of a string array or a regular string, which it will then proceed to parse by itself. So first I want to talk about why I created the package, what insufficiencies I found in other packages that do a similar thing. First, I wanted total customization. That means that I can provide an abstraction of how to create the things, but in any way I am not enforcing them. The user is free to do as he pleases. This is um, this is correct for the commands. They can be managed, activated without any other thing. They are simply classes. The arguments can be individually verified and modified during the runtime if needed. They can be further extrapolated. That you can choose to which type of variable do you parse an argument. If you want it to be a string, if you want it to be a decimal, an integer, and so on and forth. Help text, both of the entire command line tool that you create and of each command specifically, all of those can be customized. The help text of the whole command line tool is generated via some information that you need to implement in a command. Metadata, for example, if you want to show who created the tool and versioning, licensing, and so on and forth, can also be either structured by a built-in class that I provide, or in a free text. You can write a string, and this is what will be shown. Organization was another thing that is often messy, really messy in command line tools. Often you find a lot of nesting in the code. It becomes very difficult to maintain, especially if you have a lot of options, a lot of commands, and it becomes very difficult. I wanted it to be separated naturally. So each command is a class, and subcommands for very complex operations can be nested commands, which is the second point. Commands can be nested basically to infinity. As long as you parse commands, you can essentially embed a CLI tool inside another CLI tool and so on and forth. An output provider, which by default in command line interfaces is the console, a terminal, a shell. Here it is absolutely customizable, meaning you can use any output writer and you can configure it. You essentially need to implement a simple interface, then provide the instance of the implementation to the builder, and it will use it instead of the console. Internally, you can use also whatever you want, which means it is decoupled from system.console. This is what enables it to be embedded. The other thing that was important to me is to have it NativeAot compatible. If anyone doesn't know, NativeAot means that the C# application will be compiled to native code instead of IL code that will be run by the .NET runtime. This will compile it to native code, enabling it to work on basically any system. It doesn't need to have .NET installed and doesn't need anything to run it. The reason this is very important is because you might not create a tool just to use yourself, but instead you will give it to other clients, other computers, and I think to understand how it works, we better start at the bottom and then go to the top. So first of all, we have the command. The command has two parts that you need to implement: the metadata, the command name, the description, and the help text of the specific command. This will be used by the builder and the CLI runner to provide essentially both the parsing and to forward the execution path to the specific command and to generate the description and the specific help text. The execution is the main entry point. It's a single function that already comes with a parameter of type arguments that through this type you'll be able to access each of the arguments that the user provides and validate them before processing it further. This method returns a value task. This was especially important because some things may be asynchronous and some things may not. A value task is sort of a best of both worlds. It can be asynchronous, but if you don't choose to have it asynchronous, it will work synchronously and not consume the additional overhead of a task, for example. A synchronous command is very similar and it derives from command. The only difference here is the main execution method. In a command, the execution method returns a value task. In a synchronous command, it returns a simple integer. The command relies on an arguments object. An arguments object will contain everything from the input. There are three types of arguments. There are named arguments, arguments that have a name and a value that you need to specify both one after the other. The argument itself starts with either 1- or 2, and a value must follow it after a space. Flags are arguments that don't have values. They can also start like name arguments with 1- or 2, and they are essentially Boolean toggles, but they must always be followed by another flag or another name argument, but not a value. Otherwise, they will be interpreted as a named argument instead of a flag. Positional arguments parsed by their position in the input. It doesn't mean that they necessarily have to start at the start of the input, because named arguments and flags will be parsed first. After those are parsed, positional arguments will be parsed according to their position. Each one will have a corresponding index starting with 0. Arguments also can be advanced. This is made for this case of nested commands so that you don't have to remember essentially in every nested command where are you in the chain of execution. So you can forward the arguments object, then the positional arguments are essentially taken a step further. Index 0 will be discarded and previous index 1 will become 0, previous 2 will become 1, and so on and forth. The argument is created by the parser class. You don't need to interact with it at all. Everything is done behind the scenes by the CLI builder. If you want, it is available for you to use, but it's not required. CLI runner is the orchestrator of everything. It organizes the instances of commands, it organizes and generates metadata and help text, it sets the required output abstractions. It is not necessarily coupled with system.console, so this is the place where you can choose your desired output provider. It then passes the arguments to the parser and creates an arguments object. It then uses this object to parse initially and choose the command, the first command at the execution. Then it injects the arguments object into this command. After everything is done, the result of the command is returned back to CLI runner, which in turn has access to it and can be forwarded to a main method in a console application or whatever else you choose. So let's start with the demo. So what I did here is essentially I created a console application. I've done some things beforehand to not waste your time. So we have the calculator solution. We have the project. Firstly, I'm using the package of the Sharpify command line interface. We already have some commands. I'm gonna delete what we have in head. So all we have to do is create classes that implement either command or synchronous commands. Because this is a calculator, it doesn't need to have async functionality. I'm gonna use the synchronous command to make everything easier. I've already added divide, multiply, and subtract. All will show some different aspects, but we'll jump into it a little bit further. First, I want to go over to the Program.cs, which is the main part. As you can see, I am not using the top-level statements, the new default version of Program.cs. I'm using the old one with the actual class and the method static void main. This is because it makes it a bit more organized to actually show how the commands are resolved and have it a bit more structured. It also gives you a little bit control over the parameters. So firstly, we can see that we have the four commands: add, divide, multiply, and subtract. So I'm going to resolve them private static, and I'm going to do read-only span of type command. It's important to use command here and not synchronous command. And commands, Copilot can already complete it, so I'm going to let it do its job. If you wanted to use some sort of dependency injection in here, you can also pass it through the constructor. You could pass everything through the constructor if you want to decouple the commands. So I'm going to change this to async task of int. Then I'm going to do var runner CLI runner. So I'm going to create the builder. Then I'm going to add the commands. I can also add a single command, or there's overloads that use other collections than a read-only span. It's very flexible, as you will see. Just to have it a bit more structured, I can also do sort commands alphabetically, use console as output writer. I'm also gonna have metadata, and there is two options for that. I can use a custom header, which I then can provide a string and put all the metadata I want there, or none of it if I desire. And this is the header that will be displayed above the description of the commands of the application that is generated. I can also do the with metadata function, and this way I already have something structured that is using the option patterns to override it. So I'm gonna do metadata, and here you can tell that there is the name. This is the name of the application, so I'm gonna put Calc. I'm gonna use Copilot to actually fill in some of this stuff. So I have metadata description, version. I can also have author, and let's just say Dave. And there's also um, a license, which I'm going to put as MIT. After this is done, we can build it. And all we need to do now is we can return it and await runner run async and provide the arguments. This is everything that is required to run the application. And now we can go over to the commands. So let's first implement the add command. So I already inherited from synchronous command, and now we can use the implement abstract class feature. So first the name. Name is the name of the command. So I'm gonna do add, and this is just a string. the class doesn't have to be named exactly as that. All that matters is this thing. This is the name of the command. There is the description. The description will be shown in the general help text. So I'm gonna do add two numbers. Very simple. The usage is where you'd show the options and everything else you need for this command. This will not be enforced by reflection or by any other thing. This is simply a text that should guide the user. The validation is something you do afterwards inside the execute method. So I'm gonna do add, and then I'm gonna do number 1 and number 2. This is very simple, and right here you can see that these are positional arguments. I don't need to specify which is which, they're taken by the position. This will be position 0, and this will be position 1, sorry, because it starts with 0, so it goes to 1. Here we have the execute method, which is the main thing they use to execute the command, and it receives the arguments object in the form of args, and this is used to actually get the arguments that the user inputted. As you can see from the Program.cs right here, so when we run async, it essentially parses the args, creates an arguments object, and then after it chooses the right command to forward it to, it injects it into here and forwards the positional arguments. Because right here you can see that, for example, if we use add, so we have something like this. We receive add 5 and 2. So the position 0 is the command, but we don't want to take it into account inside add because that just adds complexity and we need to think about where we are. So it essentially forwards that. So what is received? It parses the command itself, then it removes it. 5 becomes position 0 and 2 becomes position 1. So let's see. So first I'm gonna start with validating the arguments, and I'm gonna do that with simple if statement. I'm gonna do args and then try get value. Here I can provide a generic that will parse the string already for me. I'll choose to do it as an integer. Now here I can also put, I can either use a position, a name if it's a named argument, and so on and forth. So at position 0, and then I can provide a default value. This is in case, in either case, I want some value to be here and I don't want it to be an error. I will try to show how it looks like afterwards. I'm gonna put 0 in for now. I can also do default of int. It's the same. And then out var a. This is very simple. Now, Copilot already completes some of that stuff, so I'm gonna let it do its job. As you can see, it already worked to the console invalid number 1 and return 1, which is a code for some error. I can also do the same thing with the second number. Now, let's say that I wanted the second number to be a 0, but not have it be an error to not provide it. So it will, if I only provide one number here, let's say I can also put this optional. So if number 2 is optional, it essentially will take number 1 and add 0 to it. And I can ensure this because I can remove this invalid number output. And I can also remove this. So I can have the output here, but essentially when I try to get the value, it will just default if it doesn't find it, and then b will be equal to the default. So I can then do this and just return 0. So if I don't provide number 1, it will return. This means that number 1 is enforced. Number 2 is optional because I don't return here. I can choose to have some output just to show that it was skipped. Actually, let's do it. number 2 defaulted to 0. Okay, so now we implemented the command. Name, description, and usage will be used by CLI runner to generate help text, both with the specific of the command and the description. I'll show you later after we build the application exactly how it's used. Um, and this is basically it. Inside the divide command, we also have it very simple. Now it's a double, as you can see. It's not an integer. And also it checks if the second one is 0 because you can divide by 0 and so on and forth. Inside the multiply, we actually used named arguments. So we provided the -a and -b to say which number is which. The way we parse it and validate is by using a and b respectively instead of the position. The dash should be ignored. It doesn't matter if there are two dashes or one dash, or it's if multiple letters or one letter. All that matters is that you don't put the dashes here and that you just put the raw thing. This is because the parsing essentially, when it chooses names arguments, it ignores the dashes so that you can use either one dash or two. It doesn't really matter. It's more of a flexibility from the user side. And also, there is another flag here that is X option. So if I use X, it will display the output in hexadecimal format, and you can see that here. The way we check for flags is args.hasFlag. I'm gonna use two if statements here, but it doesn't matter. It's essentially if you don't have the flag, if the user didn't provide hex, then it will just display it in the normal format. And as you can see, it's also not an error. It will be checked without the dashes, same as the name arguments. In subtract, it's also the same. I put integers here and hexadecimal. Actually, I'll remove hexadecimal from the multiply command just to reduce the complexity. We don't need that because we have it in the subtract. Okay. So we'll just have the named arguments here. And this is basically everything we needed. When we go back to Program.cs, we already have the instances, we already injected them, sorted them, we set the output writer, and obviously inside the commands, we don't also have to use console.writeLine. If we use another output provider, we can simply inject it via the constructor and then use it here or use it via global services class. There's many ways to do whatever you want. The flexibility is key in this package. Now let's go back to, I think it's time to build this thing. And I already have two tabs. One is inside the root of the app where the CS project is, and another is where the published executable will be. So I'm gonna use the .NET bundle command, and this is mainly to bundle it inside the Mac OS so it does know how to produce the executable and how to run it. You don't need to worry about this, but if you want, I can perhaps make a video about that. So I'm gonna build it. As you can see, it's generating native code, and it's built it without any warnings, without any errors. And it provided me with the output directory, which I already have open in the other tab. So here, if I do ls, you can see that I have calc.app, which is the packaged macOS app, and also I have the calc, which is just the executable. It copies it anyway, so I can just use that. So I can do calc. And first, if I don't provide anything, it will obviously show an error. See no code specified, no command specified. If I use help, it will then give me the generated help text. As you can see, the Calc, which is the name of the application, as of setting the metadata, description, author, version, license, and so on. Then it shows the commands. The commands are sorted alphabetically, and also they show the description of each command. And it shows you how to get help for a specific command, which is basically to use the command name following by help. So let's start to, for example, we'll see the help text of the subtract. So I'm going to do calc subtract help. As you can see, it shows me the usage. Subtract number 2, number 1, 2, and options. The options are hex to display the result in hexadecimal. We can try it. So we can do subtract. And let's say 15, and I'll subtract 1, which is 14. And it shows you the right way. I can also provide the flag hex, and then it shows E, which is the correct representation in hexadecimal. Let's see the add function that we implemented. So we can also do calc and then add 14 and 1. And it shows 15 the right way. We can also check the add command. And as we saw, the second number is actually optional. It will just default to 0, and it will show us that it was defaulted. So let's check this. If I don't provide it, add 14, it should add 14 and 0. And it shows number 2 defaulted to 0, and 14 plus 0 equals 14, which is obviously correct. It's just for the example. If we, for example, have put a double here, this will show an error because I'm trying to parse an integer, as you can see. So 14 and a half, invalid number 1. I can also, as you saw, I can write anything here in the validation. So this is basically it. We can also try to check the named arguments inside the multiply. So let's do that. Let's do calc, multiply, and minus a. Then let's do 5 minus b, 4, and this will give us 20. As I said, the number of dashes doesn't really matter, so I can do minus minus a and minus minus b, and it will also be 20. This is made essentially for the user's flexibility, because sometimes you don't remember if you need to have in the sum option 1 dash or 2 dashes, then you need to write the command again. This way, it doesn't really matter. The divide command actually doesn't have any other special thing that I wanted. It's essentially the same as add, except it does invalidate for number 2. But we'll check it anyway. So I'm gonna use divide. Let's do 20 by 5, and it will give us 4. So this is essentially everything that we needed. We can see that we did the validation in a sort of easy way because the try get value gives you a nice API to work over it. You can provide the type in the generics. You don't need to try and parse things yourself. It's very easy to validate it. It's very easy to just use defaults like we saw in add right here. And all of that without using reflection at all. And this is very important because we saw that this executable was actually compiled to native code. It doesn't depend on the .NET runtime. You don't need .NET in your system at all to run this. You can ship it to any client that uses the same, CPU architecture and operating system. For example, this was compiled to macOS with ARM64 because I'm using an M2 MacBook Pro. And after that, there are no dependencies that you need to worry about. The client can run it, they use it as much as he wants to. So obviously the code for Calc is inside the demos thing in the main Sharpify repo. The main repo link and this specific link will be in the description. So be sure to check it out. I have some ideas about what to show you next, but we'll see that as it goes. If you have any requests, post a comment. If you have any issues, obviously post them in the repo. Um, Thank you very much for watching, and we'll see you in the next videos.